As mentioned before, this malware consists of two components: a portable executable file, spark.exe, and the Windows driver file, rkey.sys. So when more than one malicious file is found on a computer, it's quite common that one of them generates others. So as spark.exe can be executed by just double clicking on it, while rkey.sys must be loaded by another component, such as the Windows Service Control Manager. So, or another driver. So we can initially assume that spark.exe was executed, and then it dropped the rkey.sys to the disk. In fact, during our static analysis of the imports, we noticed that the spark.exe has APIs to deal with this Windows Service Control Manager. And what we're going to do here is we're going to get the spark.sys to GDRA, and we have the portable executable, something like that, and we imported it. So we'll double click on it to analyze, and after that click on yes and analyze. That's it. So it's a quite simple and small file. Simple because as you can see, it's already analyzed here. So what we're gonna do is we're gonna go to bytes here, this bytes. We will display the bytes here, and here we have the start here. I will note that on the screen, or instead we have the notepad, right? Or sticky notes. Yes. So not now. Okay. So here our start is 00, 00, 01, 00, and 00 here again, and end this here. I'm talking about this start at end. We will note that, and here our end is ff, df, ff. Let's actually make it uppercase: ff, df, ff, and ff. Right. So why I noted this files, you will understand right now, because here this file starts with this pattern, right? Let's actually get this at the top here. This is the top of the file that starts. So here this file starts with this pattern. So we will also notify that start pattern. Note that here for D 5A 90 and 00, and so on here, and others. So here, as you see, this is our start pattern, and the starting bytes are also used as the signature of files. So these signatures are also known as magic numbers or magic bytes. So in this case, the signature indicates that this file is portable executable, which is the file format for executables, object code, DLLs, and others used in 32-bit and 64-bit versions of Windows operating systems. So you will see this pattern every portable executable files, object code, DLLs you analyze on the reverse engineering operations. So here let's actually use our executable file. It's already analyzed, but we can check that. We have rkey.sys. We also have the post malware. So here, as you can see in post malware, our bytes also starts with for D5A 90 and 00. So you will see this pattern very common in the executable files, object code, DLLs, and others used in 32-bit and 64-bit versions of Windows operating systems. So we can also just close this post malware, but it can stay here. No. Okay. So we can also calculate the difference between the start address and the end address. And in order to do that, we will go to search or window. We will go to window and we will select the Python from it. Python. And here what we're gonna do is resetting Python. We will subtract this here. Subtract this here, in this case hex 0x go to here. Here. And now we will go back to Python. So we will calculate this, right? So 0, 0, 0, 1, 0, 0, 0, 0 minus 0, 0, 0, 1, 5, 1 and FF. After that, close this brackets. Now here as input. Oops, sorry. We need to add 0x here. And here, this is our output. So 0x, 5, 1 and FF. So then we can open the, let's actually close this. So we can open the spark.exe and look for the file by clicking on the search and memory here. And we will paste this code here that we got from this. The search pattern. So we will paste this, the search pattern, and here this is it. And you will see here we have, let's search all. So you will see the two occurrences of this header pattern. So the first one corresponds to the header of the file we are analyzing. In this case, it's spark.exe, while the second one corresponds to the embedded rkey.sys, which is we just analyzed here. So here, this is that 00 label. It also has labels, but we have the image.dos header here. Yes. So as we know that it starts with the 004F here, location here. So we will note that down. Oops. That's not a good marker here. So we already know that it starts with the, let's instead of writing things here, let's note it down so we can read it. So location of that 004 F6850. 6850. And so we noted it down, and after that we will select the bytes here, search, or select here and select the bytes here. So here we will enter the length, right? The length is, we got this, my calculation here, and here we selected our bytes. So by right clicking on the selected bytes and choosing extract and import, right here, extract and import, which is also available, also has the shortcut. So we get this screen. where a data file is added to the project containing the selected bytes. So we identifying the malware components here. Now let's actually, we can also analyze it here. That's it. And here in imports, oops, not a program file. And here we also have the, in data type manager, we have 3 data types, spark.exe.data here. We have this data file. And we have the program trees here. We can refresh it and so on. So we can go to the active project, start exe here, program tree, symbol tree, rk.sys, and here we have this. We can see the spark.exe data here separately, and that's it. We have found this rk.sys file from our executable file, right? And here we have this in the Ghidra active project. Here we can see this, all the malware components. Now in next lecture we will analyze the malware from the entry point of the program. See you in next lecture.